Jai Hind to all. My name is Dhanshri Parihar, Assistant Professor, Department of Computer Science and Engineering, Ajay Kumar Garg Engineering College. Today, my topic is Memory Unit. My topic contents are memory hierarchy, main memory, and cache memory. Today, I am going to discuss about the various types of memories that exist in a computer system, and the main memory, RAM and ROM chips, and their chip selection, and the address mapping technique, and the introduction to cache memory. Now let us first of all discuss the memory hierarchy. In a memory hierarchy, at topmost level, we will find registers. And then the second in the memory hierarchy is the cache memory. Then we have a main memory that is comprised of primary memory, that is RAM and ROM, that is random access memory and the read-only memory. Then at the bottom, we are having magnetic disks and magnetic tapes. Now, why registers are at the top of the memory hierarchy? As we all know that the registers are the fastest units in terms of storage. Why? Because they are very small in size. Next, we are having cache memory. The cache memory is generally, we can say, a memory which will lie between the CPU and the RAM memory. Again, the storage space in a cache memory is limited, and the most frequently used information will be stored in a cache memory. Next, we are having a main memory. The main memory is comprised of RAM and ROM chips. Then we have magnetic disks and magnetic tapes. Now, magnetic disks include like we have CDs we are having previously, and the magnetic tape includes we have the cassettes, recordings, the video cassettes and all. That will be the example of magnetic tape. As in this particular block diagram, we can see here that cache will lie between the CPU and the main memory, where the CPU is able to access both the main memory and the cache memory. Now, what is the cache memory? The cache memory will store the content which is present in the main memory. Which content? Which is most frequently used by the CPU. So, what we will do? What the CPU will do? CPU will copy that content from the main memory into a cache memory. Now, what is the input-output processor? A processor which deals with the input-output devices and your main memory, that is the RAM memory. So here, what we are having in outputs, as we know that the hard disk, magnetic tapes, pen drives, these are external to the motherboard. So they are not fabricated on the motherboard. They lie outside your motherboard. So that's why this memory is known as a secondary memory, which is not on board on the motherboard. That is magnetic tapes and magnetic disks. And one more thing about this hierarchy is that the topmost memory unit will be always costly, and the lowest most will be somewhat, we can say, near about that cost, because their size is big. So we can say they are costly, but not as that much of that of the register. Now next is the main memory. In the main memory, we are having two types of memory. One is the RAM memory, that is random access memory, and another is the ROM memory, that is the read-only memory. Now, RAM is we can say a memory which is used by your CPU system. Here we are considering RAM to be of size 128 into 8. That means when we write the memory size in this term, how we can see this? This is like this: 2 raised power n into m, where n is the address lines and m is data lines. We can see. So into 128 into 8, how we can write this 128 into 8? 2 raised power 7 into 8. So we are having 7 address line in this configuration, and 8 data lines in this particular configuration. If we are considering RAM to be of size 128. Here we are having 5 input lines. These are namely CS1, that is chip select 1. Then we are having CS2, chip select 2, RD, the read line, WR, that is write line, and AD7, that is the address. The address line which is going to select this particular RAM chip. So in accordance with this particular block diagram, we are having one, we can say a truth table or a functional table for this particular chipset for a single RAM. And in this particular table, we are having chip select 1 input, chip select 2 input, read input and write input. And accordingly, we are having some functions for them. Now, what is chip select 1 and chip select 2? As we can say in this block configuration diagram of the chip select, what we can find here, we are having 4 RAM chips and 1 ROM chips configuration. Here we are taking the instruction to be of 16-bit. Out of 16-bit, 1 to 7 bits are used for addressing these 5 chips, 4 RAM chips and 1 ROM chip. And why we are taking this to be like this? Because we are taking the complete memory of 1024 size, out of which 512 will be for ROM chip and 512 will be of RAM chip. And we are going to divide this 512 chip into 4 parts. So we are having 4 RAM chips in this particular configuration. In this example, we are considering. Here, out of 16-bit, the first 1 to 7 bits are for, we can say, addressing the RAM lines. And then the 8th and the 9th bit is used for making selection among the RAM 1, RAM 2, RAM 3 and RAM 4 chip. Out of any 4, only 1 will be selected at a time. So that's why we need 2 bits, bit number 8 and bit number 9 to make that selection. And how we can do this, we can discuss it earlier. Further, the next is the 10th bit. 10th bit is used to make a chip selection among these 4 RAM chips. Out of this 4 RAM, either a RAM will be selected or a single ROM will be selected. So make that selection among these RAM and ROM chip, we will use bit number 10. And we will insert certain value in this bit number 10 for making that selection, either 0 or either 1. That I will be going to discuss further. Then we have bits 11 and 16. Now from bit number 11 to 16, these are empty. This is not used for this chip selection process. So let us start the procedure of chip selection. How we can perform this chip selection, which of the 4 out of 4, which of the RAM chip is going to be selected, and either a RAM chip is going to be selected or either a ROM chip is going to be selected, how we can perform so, how a CPU can perform so. If a CPU is issuing a 16-bit of, we can say, instruction. So how we can segregate those bits for selecting, making a selection among a RAM chip or ROM chip. Now, if a CPU is issuing 16-bit of, we can say, instruction, what will happen? The bit number 1 to 7, these are connected to the address 7 line of RAM 1, RAM 2, RAM 3 and RAM 4. Okay. And from bit 1 to 7, some address will be of 7-bit. That will be either a address of RAM number 1, either will be an address of RAM number 2, RAM number 3 or RAM number 4. How we can know about that address? From this AD 7-bit. So among these 4, only 1 will be selected. Which one? Whose address is present in that 7-bit of configuration issued by a CPU. That 16-bit of instruction being issued by a CPU. Out of that, the first 7-bit are used for addressing these RAM chips. Any one out of 4. Now next is the bit number 8 and 9. Now these both chips are used to know whether the RAM 1 chip is activated, whether the RAM 2 chip is activated, 3 is activated or 4 is activated. And how we can know that? We will put a decoder over here that will convert. That is a 2 into, this is a 2 into 8 line decoder. 2 into 4 line decoder. What this will do? It will convert a 2 bit of data into a 4 bits. Now suppose the value of bit number 8 and 9 is 0 and 0. Then the output signal 0 will be generated, and this 0 output signal is connected with chip select 1. So the chip select 1 of RAM number 1 is activated, and all the other chips will be disabled at this moment. Why? Because the 00 address will be activating the line CS1 for RAM number 1. And the CS2 is initially not receiving any signal, meaning it will be at 0 value. So chip select 1 and 2 is used for making a selection among RAM and ROM. Chip select 1 is used for selecting the RAM chip, and chip select 2, CS2 bar, is used to making a selection for a ROM chip. Right now we are talking about the RAM chip, making a selection among the 4 RAM chip, which one is selecting. So if 00 address is being issued by the bit number 8 and 9, 2 bit will be 00, then the decoder output will be at 00, and the chip select 1 of RAM number 1 is getting activated, this one, and the RAM 1 will be getting selected. Similarly, if here the value will be 0 and 1, this will be 0 and 1, then the decoder output will be at bit number 1, and then the chip select 1 signal of RAM number 2 will be activated, due to which the RAM 2 will be selected at this moment when the bit number 9 and 8 had be 0 and 1. And if it will be 1 and 0, then the value of bit number 9 and 1 will be 1 and 0, then the output of decoder will be at bit number 2, that is 10 binary code, and the RAM number 3 will be selected for chip select 1. As a chip select 1 of RAM number 3 will be acted at signal 1 and 0. And then this line will be activated for RAM number 3, that is chip select 1 line. So out of any 4, only 1 will be selected at a moment. Similarly for RAM number 4, if the input value, that is 9 and 8, will be at 1, 1, then this will be activated, bit number 3 will be activated, the binary code for 3, decoder output, and then we have a RAM number 4 chip to be selected. By using this chip select, 1 bit will be activated for RAM number 4. So this is how we can make a selection among the 4 RAM chips. But only 1 RAM chip will be selected at a moment. Now let's come to the next making a difference between how we can make a selection among a RAM chip and a ROM chip. So that will be done with the help of chip select 2 bar bit. Now we will come to bit number 10, this bit. When the value of bit number 10 is 0, what will be input to the 4 RAM chips? If it is 0, the bit number 10, here this is the line for bit number 10, it will be going to chip select 2. Chip select 2 bar means when its value will be 0, a 0 will be inserted in RAM 1, RAM 2, RAM 3 as well as RAM 4. So the value of chip select 2 bar is equals to 0 for RAM 1, 2, 3 and 4. And similarly it is 1 for ROM chip. Why it is 1 for ROM chip? Because we are putting a NOT gate in front of chip select 2 in a ROM chip. When the bit number 10 will be 0 for all other blocks, it will be working 1 for this ROM block. And at that moment, when the value of CS2 bar is 0, a 0 will be inserted, it will get inverted, and for ROM chip it will become 1. And at that moment, the ROM chip block of configuration 512 into 8 will be selected. Okay. And what about this chip select 1? This chip select 1 is not functional for this unit. We can say whatever be the value of this chip select 1, this will be not hampering our, we can say, selection process of a ROM chip. And let's come to the next lines like reading and writing lines. So this is all about making the selection between RAM and the ROM chip. How we can do so, how a 16-bit of address will be converted into some particular bits, and that bits can be used further for making the selection. Now next is reading and writing operation. How reading and writing operation is performed. As we all know that the RAM is a random access memory, it is a volatile memory. So here we can perform the reading as well as the writing operation. But in a ROM chip, we can perform only the reading operation because it is only a readable memory. It is not a writable memory. So here there is only one, we can say, signal, that is only a reading signal, we can say, not your writing signal. Only a read selection line will be here. But here in RAM chips, what we can see, we have a reading lines also. So when the value of this read will become 1, then that particular RAM which is selected through chip select 1 or chip select 2 input, that particular RAM will be readed. And when the value of this write will be 1, then out of 4, any one of the RAM that will be selected at that moment will be writed. Means a writing operation will be performed on that particular RAM. Now what is this data and data bus? The data which is outputted from these RAM, and this will be flowing in the data bus and going to our CPU. That will be stored in the RAM and then will be taken out from the RAM on a data bus, flown the data bus, and will be sent to your CPU. So that is data bus, we can say, an output lines. Now this data bus will be of size what? That will be of size 8 bit. Why 8 bits? Because in this configuration we are considering a main memory of 1024 into 8, where we are having 512 to be a ROM chip and 512 to be a RAM chip. Here 8 will be the number of data lines in this particular memory, and this data bus is then be of 8 bits for this particular configuration. And that will depend upon the memory configuration what we are taking. If we are taking some other memory configuration, 1 GB or something else, then the data bus size will be different for that particular configuration. Now this is all about how we can map this thing. Now for ROM lines, we are not having address line 7. These 1 to 7 address lines are only reserved for your RAM chips. Now what about ROM chip? The address line number 9, that will be including 1 to 7 as well an 8 bit and 9 bit. The 8 bit and 9 bit which will be working as a selection process, which will be helping in selection process of RAM chips, will be acting like a address line for the ROM chips. So we will discuss this, how these address line can help in forming an address of particular chip and selecting that chip. So 8 and 9 will be working as an address line for a ROM chip, and for RAM chip it will be helping in a selection process. Now the bit number 11 and 16, these are empty and they are of no use in this particular configuration. So their value will be always 0, binary 0. Now let's move to this mapping technique. Before that, we will have a look at this RAM chip truth table, how this reading and writing operation will be performed on which binary values, what will be the value of binary bit at CS1, that is chip select 1, and then chip select 2, and reading and writing values. Now when the value of chip select 1 is 0 and chip select 2 is also 0, it means no chip is selected at that particular moment at 0, 0. Neither the RAM is selected, neither the ROM is selected, neither the reading operation is performed, neither the writing operation is performed. At that state, your data bus will be at high impedance state. High impedance means a very low current is flowing in the circuit. There is no movement of any information on your data bus. That is a high impedance state of a bus. Now, when the chip select 1 is 0, means RAM is not selected and chip select 2 bar is 1. It means again the RAM is not in the selection process and chip select bar is 1, means either that ROM is not selected and neither the RAM is selected, again we have a high impedance state and no reading and writing operation will be performed. Actually, this truth table is only for the RAM chip, not for the ROM chip. So here we are discussing only about the RAM chip selection and its outcomes. The next is when chip select 1 is 1 and chip select 2 is 0. Neither the reading and writing operation is performed. That the value of reading is also 0 and writing. Here we are having X. X means don't care. We don't bother about whether the value of the binary bit will be 0 or 1. So we are not bothering about the reading and writing bits because as we know that here the RAM chip is not selected. That's why we are not bothering about reading and writing operations, because when the chip is not selected, where we are going to perform that reading and writing operation. So we are not bothering about the values in reading and writing bit. But here, when chip select value is 1, it means any one out of 4 RAM chip is selected. So we have to know whether we have to perform a reading operation or a writing operation. As we know that the binary value can either be 0 or either be 1. This is the case when the reading and writing value will be 0, 0. Again, no operation will be performed. High impedance state of a bus. Again, it is 1. Chip select 2 is also 0. Means the RAM is selected. The reading value is 0. But the writing value is 1. So, writing operation will be performed on a RAM chip. When chip select is 1, reading 0. Chip select is 2 is obviously 0 because that is for selecting a ROM chip. And a writing bit is activated, a writing operation will be performed and the data will be input into a RAM. Writing means writing into a RAM, inputting the data to RAM memory. Then we have a reading operation. In a reading operation, the value of read bit will be 1. Again, the chip select 1 is 1 because RAM is selected for performing the reading operation. And this is again 0. The ROM is not selected. Reading is 1. Writing we don't care about because we are performing a reading operations. So, the output we will send the data from RAM to a CPU. That is an output operation. Then again, when both value is 1, means chip select 1 is also 1 and chip select 2 is also 1. That is not going to happen in your system because we can't select RAM and ROM chip at a same moment. Because of complexity, we can't perform so much operation at a same moment. So, here again, we don't care about the reading and writing operation. Again, high impedance state will be the state of the bus and no data will be flowing to a bus or either will be taken from a bus by a RAM chip when both the lines are activated. So these are the possibilities, these are the cases where the value of chip select 1 and chip select 2 will be 0, 0, 0, 1, 1, 0 or 1, 1. The 4 possibilities and their different kind of, we can say, functions performed on the basis of that inputs. So this is all about the RAM selection and its operation performed in the memory, we can say. Now next is the ROM chip. Again, in a ROM chip, we are having chip select 1 input and chip select 2 input. It will be a configuration 512 into 8 and we have a 9-bit of address in this and 8-bit of database. Why 8-bit of database? As we know that 512 into 8. 8 will be your data lines. That's why 8-bit of database. Now let us come to the address mapping of these ROM and RAM chips. How we can calculate what address will belong to a RAM chip and what address will belong to a ROM chip. So this will be the table for that, we can say hexadecimal addressing, how it will be performed. As we know that the data which will be sent by the instruction that will be sent by the CPU will be of 16-bit and out of 16-bit, 1 to 7 will be reserved for addressing our RAM chips and then 1 to 9 will be reserved for addressing our ROM chip and rest, that is from we can say 11 to 16, that will be of not any use and the 10th bit will be decided whether the selection will be among RAM and ROM chip. So how that can be possible, how this table can be obtained from that, let us understand this thing. Now let us make a table where we are having 16-bit of data. We can say 16-bit of bit 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. Why 16? Because here we are taking a 16 bit of instruction. Let us put it like this. We can make a table. And here we are having the RAM chips. How many RAM chips we are having? 4. RAM 1, RAM 2, RAM 3, RAM 4, and then 1 ROM chip. Okay, like this. As here we are seeing that the address will be of this, the instruction will be of 16 bit. So it will belong to a hexadecimal number system. Hexadecimal number system, that will be from 0 to 15 we can say. And what will we do? We will perform a pairing of 4 and 4 bits. 4 bits, because the number system is hexadecimal number system, and we can segregate this 16 bit into a 4 bit of combinations. Now before performing that, let us first put the values in this 16 bit. What will be the value for RAM 1, what will be the value for RAM 2, RAM 3 and the ROM chip. As we know that from bit number 1 to 7, we are having some address bits for these RAM chips. So we will be putting some cross over here. Cross means don't care condition. The value may be either 0 or that will be 1. For all the RAM chips, we will put in cross over here like this. Afterwards, we will be putting some binary values in it like this. Why 1 from 7? Why 1 to 7? Because that is reserved address for our RAM chips. Then about ROM chip. In a ROM chip, we have a 9 bit of address. So we will put in cross in a 9 bit of, you can say, combination from 1 to 9. So what about 10th and 9th bit for RAM chips? For RAM chips, 10th and 9th bit is acting as a selection process for selecting that particular RAM chip. For RAM number 1, the value of 9th and 8th bit will be 00, 01 for RAM 2, 10 for RAM 3, and 11 for RAM 4. And for ROM, it will be working as a address line, we can see. Now, what about this 10th bit? In that mapping, we can say block diagram, what we have considered a 10 bit, a decision making bit, which is making a selection among a RAM and a ROM chip. So the value of 10th bit will be 0 for all the 4 RAM chips and 1 for the ROM chip. So we will insert 0 over here like this, and 1 for 1. Why? Because when the 10th bit is going to be 0, only the ROM chip will be getting selected, not any of the RAM chip. And what about these 16 bits? We will be putting a binary bit 0 over here, because that will be of no use to us, because we are not using this 11 to 16 bit. So we are putting 0 over here, including the 16 bit also. 0, 0, 0, 0, 0, 0. Again 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Let us make this more clear. And we will be, because this is a 16 bit we are putting the value to be 0. And here we are constructing one more line for this RAM. RAM 1, 2, 3 and 4. Then we have this is a ROM chip, okay, like this. RAM. And we are putting this value to be 0 for all these contents. Now how we are going to know about the address? What will be the address? We can say a range for selecting a RAM 1 chip. How we can decide that? We are just making the pair of these 4 bits, 1 to 4, then again 1 to 4, then again 4 bits, and the last 4 bits. Now first is the lowest value of, we can say, address. So we are putting here 0, 0, 0, 0, 0. That is when all the bits are having 0 value. If we combine them, this 4 bits contributes to the 0, we can say binary 0. These 4 bits again contribute to binary 0. Again the next 4, 0. And the next 4 again 0. So lowest range for RAM 1 will be, address range for RAM 1 is, lowest range is 0. We can say hexadecimal 0000. This is the lowest range. And how we can perform a highest range for this? We can put all 1 from 1 to 7, we can say, like this. So here we are putting it to be, we can say 1, 1, 1, 1. But only up to bit number 7 we can say. Why not 8? Because we are considering only the 7 bit of address. One time you will fill it as a 0 with binary bit 0, and one time you will fill it as a binary bit 1. So what will be the 4 bit combination for this configuration? This will become 1. The first one will become 1. Then this will become 7. 0 triple 1, 0 1 1 1. That is not this. This is the lowest range will be F. This will become F. Not 1. This will become F. This 4 buns. Then 0 triple 1 will become 7, and again 0 and again 0. So what will be the highest range then? It will be 0 0 7. So this is the address we are range which is used for RAM number 1. Similarly, we can use the same process to find out the range of address for RAM number 2. For RAM number 2, if we are putting all the values to be 0, 0, 0, 0, 0, 0, 0, 0. So one range will become 1, 0, 0, 0, then 4 zeros, and it will be like this, we can say. So range will be lie between this and this. Similarly, we can find out the range for RAM 3, 4 and for the ROM chip. Thank you. Jai Hind.